In this video, we will discuss solving the system of linear equations. Consider a system having one equation that contains only one unknown. Ax equals to b, where a and b are element of real numbers. The unknown in the given equation is x. So, we can write the value of x as x equals to b by a. The solution of the x is dependent on the values of a and b. If the value of a is not equal to 0, then the system has a unique solution. The solution is x equals to b by a. If the value of a is equals to 0, the equation looks like 0 multiplied by x equals to b. So, for any value of x, the left-hand side of the equation is 0. That is, 0 equals b. Now, the right-hand side is equal to the left-hand side, only when the value of b is equal to 0. So, for the value of a equals to 0, the value of b has two possibilities. For b equals 0, the equation is satisfied for every value of x. And, for b is not equal to 0, the equation is never met. So, to summarize the information, when a is not equal to 0, the equation has unique solution, which is x equals b by a. When a equals 0, there are two possibilities. If b equals 0, the solution has infinitely many solutions, namely, x can be any real number. Then, the equation is called identity equation. If b is not equal to 0, the equation has no solution. Then, the equation is called contradictory equation. Let us consider a system having two equations, which contain two unknowns. X plus 2y equals 1, and x plus 4y equals 1. To solve the systems having two equations, there are different methods available. Graphical method, substitution method, elimination method. In graphical method, let the two equations be 1 and 2. We will draw two lines on a graph containing xy plane. Find the points of intersection of the lines on the x-axis and y-axis. For this, we need to substitute x equals 0 and y equals 0 in both the equations. Then we can see that the first line is passing through the points 1, 0, and 0, 0.5, and the second line passing through the points 1, 0, and 1, 0.25. Mark the points on both the axis, and connect the corresponding points, and extend the lines. These two lines represent the given two equations. By observing the two lines on the graph, we can say that they intersect at a single point. This is the solution for the given system, which is a point x, y equals 1, 0, that is x equals 1 and y equals 0. In substitution method, we will take one equation first. So, let us take the first equation. Now, find the value of x in terms of y, or y in terms of x. So, let us write x in terms of y. We get x equals 1 minus 2y. Substitute this value in the second equation. By solving the equation, we get the value of y equals 0. Now, substitute this value in the value of x. Then, we get the value of x equals 1. Hence, the solution is x, y equals 1, 0. In elimination, or addition method, we will add or subtract the two equations, in such a way that, either the x terms, or y terms cancel out. So, let us take the equations 1, and multiply it with constant 2, on both sides. Now, subtract the equation 2, from this equation. Then, the y terms cancel out, and we get the value of x equals 1. By substituting the x value in either of the equations, we get the value of y. So, the solution for the given system is x equals 1 and y equals 0. The substitution and elimination methods are simple methods that can effectively solve most systems of two equations in a few steps. If we want to solve systems of 3 or more equations, these methods become unfeasible, or impossible. So, for solving complicated systems, we use augmented matrices. Let us see, how can we find the augmented matrices? Augmented matrix. Let us assume a system of 3 equations. We know that we can write the system of equations in a matrix form of Ax equals to D, where A is a coefficient matrix, X is a variable matrix, and D is a constant matrix. The augmented matrix is created by appending the constant matrix to the right side of the coefficient matrix, and by separating them with a vertical line. By performing elementary row operations on the augmented matrix, we will bring the augmented matrix into a row echelon form. In the row echelon form matrix, there are 1s in the main diagonal, and 0s in every other position, except in the right side of the vertical line. By doing back substitution, we can find the solution of the given system. We will discuss elementary operations and echelon form matrices more clearly in the next lectures. In this video, we have discussed solving the system of linear equations.